Hey everyone, Miss Delito here. We're going to take a look at representing fractional increases and decreases with tape diagrams and equations. So we're going to write some equations to represent each tape diagram here. And let's start by determining which is an increase and which is a decrease. So in example A, we're starting with x and we've got a bar that represents y. So when we go to write our equation, we want to think about what's happening to x. Are we adding a box to x, or are we taking a box away from x in order to make this tape diagram the same as y? In this case, we're adding a box to x, so we know that this is going to be an example of an increase. So now what we need to do is we're taking a look at x. These three shaded boxes make up x. And each of these boxes, since it's split into thirds, represents 1/3 of x, or 1/3 x. We can't simply just say 1/3 because we don't actually know what the value of x is. The value of x could be 9, and if the value of x was 9, each of these three boxes, each one would represent 3. If the value of x was 18, each box would represent 6. So until we know what x is, we're going to say that each box represents 1/3 of whatever x might be. So we see one box that's the same size is being added to this tape diagram to make this top bar the same as y. So we know that 1/3 of x is being added to 1 whole x in order for it to equal to y. So an example of an equation that would represent this is y is equal to that 1 whole x, these three boxes, plus another 1/3 of x. We also could say that y is equal to or the same as 1 whole x and another 1/3 of x, or 1 and 1/3 x. So let's take a look at tape diagram B. Again, we're starting with x and something's happening to it. We're either adding or taking away from x to make it the same as y. In this case, we are adding two boxes to make this top bar the same as y. So again, we know this is an example of an increase. X is still being split into 3, so we know each of these boxes represents 1/3 of x, whatever that might be, which means that these two boxes that are being added also are representing 1/3 of x. Since we're adding two boxes, we need to add 2/3 of x in order to make this the same as y. So to get y, or what y is equal to, we're starting with x, 1 whole x, those three boxes, and we're adding 2/3 of x. Or we could also say that y, this bottom bar, is the same as 1 whole x and another 2/3 of x, or 1 and 2/3 of x. Now let's take a look at the bottom two tape diagrams. In these situations, it's going to look a little bit different. So we're starting with x, and something is happening to x in order to make this the same as y. So we have to take something away from x in this situation, which tells us then that this is going to be an example of a decrease. So we take a look and we know this whole bar up top is representing x. Again, it's split into three boxes, which tells us that each box represents 1/3 of x. So we know that in order to make this the same length as y, we have to take away one of those thirds of x's. So y is equal to our x that we're starting with, and then we're taking away or subtracting 1/3 of x. When we take away or subtract 1/3 of x, we can see that there are 2/3 of x's left, or y is the same as 2/3 of x. So both equations will represent this situation. The last one here, again, we can see we're starting with x and we have to take away part of x in order for it to be the same as y. So again, we know this is going to be an example of a decrease. Because x is split into 3 boxes, we know each box represents 1/3 of x. And in this situation, we need to take away 2 of those boxes in order for that to be the same as y. Or we need to take away 2/3 of x to get y. So y is equal to the x that we're starting with, that whole bar, taking away 2/3 of x. Or we can simply say y is equal to, or y is the same as, when we take away those 2/3 of x, it's the same length as 1/3 of x. So now that we've written our equations, there's a couple things that we can still think about. When we see an example of an increase, like we did up here, we notice that in our simplified expression or equation that we have more than one whole x. And we know if we're adding something onto x, we should have more than one whole of that x. We also know if we're adding something on, the operation that we should see in that equation should be addition. We're adding to x. In our situations for decrease, we're taking something away, so we should see that subtraction in our equation. Or we know that we're starting with a whole x and we're taking away part of that x, so we should only be left with a fraction of x, or part of x, or less than one whole of x. So now that we've written these equations and we see what the tape diagrams look like, let's see what these actually look like in terms of a situation. So Giselle ate X pounds of blueberries. Rory ate 1/3 less than that. So I'm going to look for some keywords here. And some keywords that jump out at me are 1/3 less than that. When I see that term less than, this tells me that I've got to take something away, or that this is going to be an example of a decrease. So immediately this eliminates tape diagram A and B as a possible representation of the situation. So in this case, we know we're starting with Giselle. Giselle ate X pounds of blueberries. Rory ate 1/3 less than what Giselle ate. So she ate 1/3 less than what Giselle ate. We're taking away 1/3 of X, and we see that here. So tape diagram C is going to represent this situation, and the equation y is equal to what Giselle ate minus 1/3 of what Giselle ate gives us what Rory ate. Or we can simply say that Rory ate 2/3 of what Giselle ate. So let's take a look at another example. Nick biked X miles. Arkins biked 2/3 more than that. When I see that phrase or idea that we have more than that, we know that's going to signal that this is an increase. So that eliminates tape diagram C and D for this option. So if Arkins biked 2/3 more than that, we know we're adding 2/3 of what Nick biked to what Nick biked. So when I look up here, I see in tape diagram B, we're adding 2/3 of whatever X is. So we're adding 2/3 of whatever Nick biked to find what Arkins biked. Our equation, y is equal to x plus 2/3 x, tells us that Arkins biked whatever Nick biked plus 2/3 of what Nick biked. Or we can say that Arkins biked 1 2/3 of what Nick biked. So Emma bought X pounds of apples and Taylor bought 2/3 less than that. So again, we see that term less than, which signals this is going to be a decrease. And we know it's going to be a decrease by 2/3. So when I look at my equations up here, or my tape diagrams, tape diagram D is where I see a decrease of 2/3. We're taking away 2/3 of X in order to get Y. Our equation, y is equal to x minus 2/3 x, explains to us that Taylor bought what Emma bought, but 2/3 less than what Emma bought. Or we can simply say that Taylor bought 1/3 of what Emma bought. Last but not least, Aditi picked X pounds of apples and Abigail picked 1/3 more than that. Again, more than that signals that this is in fact going to be an increase. And since we only have one tape diagram left, we know it's going to be tape diagram A. But just to prove that, again, this is an increase by 1/3. So we're adding 1/3 to X, which we see in our tape diagram up here. And the equation Y is equal to X plus 1/3 of X tells us that Abigail picked what Aditi picked plus 1/3 of what Aditi picked. Or we can say that Abigail picked 1 1/3 of the amount of apples that Aditi picked.